Hi, everyone. Thanks for coming in for our talk. Today, we'll be talking about intelligence-driven user communications at scale. Starting off with some introductions, my name is Gaurav. I work as a backend engineer at Uber. I've worked on various teams at Uber. Right now, I'm part of communications team. Prior to that, I was on fraud platform. And prior to Uber, I was working at Microsoft on question answering systems and distributed systems. We have Manny here. He has a ton of experience writing CAD software, followed by a lot of experience in data infra at LinkedIn, various things at Uber, including communications and data. And most recently, he's an engineer at Databricks. We have a third person who couldn't be here today. Her name is Manisha. She is an engineering manager at Uber. She has managed various teams like conversational AI, fraud platform, and communications team. So the work that we are presenting today is communications oriented. The agenda for today's talk is going to be, we'll share why we do what we do, what our mission statement is, what drives us, followed by some terminology which will be useful in the rest of the talk because there is some domain knowledge here. Then we will dive deeper into the architecture and the vision of where we are going generally as part of intelligent communications, share some numbers around what is the scale we are looking at, and some deep dive into use cases on how we are using that architecture to light up certain use cases. At the end, we will also have some time for Q&A, so please save your questions. Starting off with the mission, our mission is driving billions of individual interactions intelligently and efficiently across wherever a user is, across many communications channels, and adapt according to how a user is interacting with those messages. So what that means is we decide what to send to a user, when to send it, and how to send it. It will become clearer as we go through the slides on how we are accomplishing that mission. Channels is a fundamental concept to us. This is the first terminology that we have. It's essentially a medium of communication. You may be most familiar with a push notification, your Uber is arriving now when you're waiting for your ride. You may have seen the in-app messages, which kind of lets you chat with the driver before the trip to make the pickups easier. There's also VoIP calls and the standard email and SMS mediums that Uber uses to communicate with its customers. We broadly classify our content in two categories, marketing and transactional. Transactional messages can be thought of as a result of your interaction with Uber. A good example would be an Uber receipt that you may have received after the trip ends. We also have marketing comms, which are promotional in nature, meaning your discount codes, thanks for signing up to Uber, here's your first ride coupon, and so on. This fundamental distinction is standard in the industry because of the routes that the underlying providers use, with higher deliverability on transactional routes and slightly lower ones on the marketing. So marketing communications are generally cheaper to send also. This is an example of what a typical workflow looks like in order to schedule a communication at Uber. So the second terminology we're introducing is a campaign. A campaign is a scenario that someone wants to run in their cities. So Uber is a decentralized company which has a lot of city ops across the world in hundreds of cities. They know their cities best. So what they do is, at the center of the screen, we have a drag and drop kind of graphical model, which they can drag and drop and decide for this city, they want to send these kind of communications out if a certain condition is met. So it's a classic if this, then that tool that we have built internally. Within this tool, they can also drag in content nodes. This content nodes lets them choose what content needs to be sent. This is essentially a template that they can drag and drop. You also see an SMS node, so they can decide if they want to send an SMS out over SMS or email or push notification and so on. On the left is an example of a personalization as part of the platform. So instead of saying, thanks for tipping Uber user, we have the first name. So CRM person would choose a template which says, thanks for tipping, first name, followed by the next sentence. It would also be customized to the language that the user has preference to. For me, it's English, so this shows up as English. For someone who has set it as Spanish, it will automatically be rendered in Spanish at runtime. On the right, it's kind of like the post-delivery stats that we collect and show back to the CRM folks so they can monitor how their campaigns are doing over time. So we have the delivery metrics, how many messages have been sent out over the last 30 days, how many of them were successfully delivered, and how are users interacting with them, including the open metrics and click metrics and so on. This works across all channels that we have. So for SMS, we have link tracking for something, and for push notifications, we have something else. And for in-app cards, we have impressions and how users are clicking on those feedback cards. Next, I'll invite Manny to talk about how we are taking this workflow and working on automating it.
Hello, everybody. We talked about campaigns and we talked about channels. If we go real quickly to the previous slide, where you have a city operator who knows her city the best, decides that, hey, I need to get a particular metric up. So if they want to hit a particular target for the number of rides in a particular week, the way they go about doing this would be they collect a whole bunch of data from previous trips and weeks of riders, that would be the demand, and drivers that are available, which is the supply, and run it through a whole bunch of models, aggregate the data, run it through models, doing it like in an ad hoc manner, assigning the amount of budget that is available to actually lift the metric, create a campaign, which is in this case a promotional campaign, and then set up a campaign using one of the tools in the middle to spray people with promotional codes or some messages that would be enticing, experiment on users, various different techniques that we all are aware of to get the metric up. The way I describe this process entirely, starting from creating this campaign to getting the data and whom to send it to, and then finally looking at the metrics that how the campaign is doing over time. There are several human steps that are involved out here. So to be able to do this best and to leverage the data that is collected across different cities, because remember, this is while it is one city and one city operator doing their best, a lot of knowledge is transferable, and a city like London might be like New York, or Amsterdam might be like Wisconsin, Madison, and so on and so forth. So to get some of this data and intelligence into place, the way we came about automating this entire process was to think of it as a multi-stage process. So if you look at the box at the top left, that is a city operator coming in and defining what they want to do at a high level. So we wanted that to be the only place where a human is involved to actually set up the objective. What type of campaign are we looking at? Is it some kind of marketing campaign, just sending out some promotional stuff about a new product coming in? Or is it like a promotional campaign or incentives that we are doling out, and so on and so forth? What is the objective? What is the objective we're trying to hit? Increase the number of rides, reduce the costs, get awareness, the target audience, eaters, drivers, riders, a combination of people. And what is finally at the end of it, how much money are you willing to spend for a particular campaign? So a human is involved there. They set up the entire campaign using the tools like the ones that we looked at in the previous slides. And then from there on, the system takes over and suggests that for this particular campaign with this kind of ROI you have in mind, this is the kind of channels that you might want to target. You might want to target SMS and email, for instance, based on the people that you've selected, based on their past histories, whether they like email better or they like SMS better, what do they engage with. That goes into feeding into actually planning out the campaign. What sort of content are we using? What sort of templates are we experimenting with? How should it look like? What is the color? So having the system sort of pre-create a message that was best suitable for that type of campaign based upon the previous experiences and ones that have been most fruitful in engagement. And then finally, the schedule. When would be the best time to send this particular email campaign out or SMS campaign out? When do you target the users? So there are several sort of steps that we wanted to automate to sort of do that, which was available through a whole bunch of data, through engagement metrics and stuff from users' engagement that we could harness. The final two boxes are when the campaign is ready to go out, how do you personalize it, right? As in the example that Gaurav gave out, there was personalization done with the particular language that is used, the user's name. Maybe the city might be a play in there. You might want to pull in some stuff that is happening in the city. So how do you sort of customize it based on something that is going to be most fruitful for the user? And then finally, the last step was something that we thought of was a pie in the sky, which would be that we are well aware of what a particular user is best engaged with. So this particular campaign that was thought of as an email and SMS campaign, let's say on the fly we want to switch it to a push notification. And here's an example where it sort of makes more sense. You have somebody who is expected to get an email for this particular campaign at 9 o'clock at night. But you see that this person is taking an Uber ride. So the system automatically detects that and sends them a push notification saying that, hey, how about here's a promo code for ordering and eats. So you know a user is already engaged with the platform, and at that point of time online, you switch that particular campaign and a message that is supposed to go out at a later stage to a different sort of a message with a different form factor, different messaging, and to sort of gain that engagement with the user. To have a better sort of a lift from the metric, given that you know a user interacts best. So looking at conditions in the marketplace, looking at the real-time dynamics, and getting some feedback on how engaged a user is, you sort of switch the campaign. So this was the big vision that we had a year or so back on how to sort of achieve this AI-driven mechanism for something that has been happening for hundreds of campaigns happening in even a smaller city week over week over week. And this multiplied by hundreds of Uber cities. So how did we come about solving this problem? We thought of this as a data flow problem while putting up the architecture together, and we looked at all the fundamental concepts that were involved in this. So first one was a user's interaction through a set of tools that we had built for the users. Like the if this then that sort of a tooling that is available to a user. But then there were already several systems in the Uber's backend that were also interacting with communication systems. So we, like for example, the receipts that you automatically get at the end of your trip. So to be able to achieve the intelligence the way we wanted to, the way we thought of this was to create a gateway layer that had a very well-defined interface, very tightly defined APIs to interact with the communication backend, and that abstraction layer to sort of have all the hundreds of different real users and systems to talk to the communication interface. The other piece was the content authorization tools that were available. How do you create who's the author? What is the target? What is the budget? And interacting with other ecosystems to sort of create that. And both of these flow into the central meaty piece of the intelligence services. At the higher level, we are breaking this out into two different, the recommendation engine and a suppression engine. We'll talk about the suppression engine in a few minutes, but the recommendation engine necessarily is going back to the example that we've been discussing, using the information that is available from the users and the schedules. What is the best content? What is the best target? What is the best ROI? And giving recommendations and about the language, about what sort of verbs to use, and coming up with all of those recommendations, that would be the central piece. And this relied on several data lakes and online resources that we had built. Finally, like for example, several batch jobs were run based using Spark on data sources that are available in Hive. And once all of the data is crunched, creating some features and some pointy sources that a user can look up and that can be used for personalization on the fly, we had Cassandra available. So the intelligent piece was a central piece that was talking to all of these data layers and sort of set up through a data abstraction layer to achieve that. And then finally, the two components that get into place was the actual deliverability, because at the end of it, we can create a campaign, but unless you have a real high-performing, low-latency, high QPS service that can send out a whole bunch of SMSs and emails at the rate that is expected to send out. For instance, in a big country, you might have millions of SMSs that are expected to go out in a small period of time. So having scalable services that can scale automatically to be able to achieve that was reliant heavily on that. And the other thing was, once you have the messages sent back, you getting back the information from these third parties that you're using to actually send out these push notifications or SMSs to get data about the actual deliverability of these messages, or how a user is engaging on these messages by clicking a particular link and so on and so forth. So the last layer was talking about getting the aggregation data back from these third-party providers, and aggregating it based on slices that is available to users to view through the aggregation tool that we've built. So once this was built, what sort of scale are we looking at, right? It's enormous. Uber sends out about 500 million different messages a day to users, and this is a combination of all sorts of messages, from SMS to emails, which are the dominant messages, to in-app and push notifications and so on and so forth. But what is astounding more is the actual events that are generated from these messages. For instance, if you engage with an email by actually opening it or clicking on a link or hitting unsubscribe, for instance, you could do that with an SMS as well by clicking a link in an SMS. So the third-party providers that we discussed in the previous slide will send all of these information back to Uber, and that information is gathered at that scale of 3.5 billion a day. And then we have a whole bunch of systems that are reacting to those messages, and a lot of it is based on streaming pipelines that aggregate those messages. Sometimes they have to be deduplicated to come down to the actual messages that were actually engagement, coming up with the engagement metrics and aggregating in time slices, so that a user, when they create a campaign that is expected to go out at 9 o'clock that we talked about, and at 10 o'clock they should be able to go in and see, how is my campaign doing? How is it affecting the other metrics? And getting that visibility from users. Are people opening it? Are people disliking it? Are people hitting unsubscribe a lot more than they expected? The two other things I wanted to bring out here is all of this is for both transactional and marketing. And different type of messages have different SLAs, and that SLA is also applied to the aggregation SLAs. For instance, if I need a transactional message, I might have a shorter latency requirement on when the message is sent, but I also want to see the events coming back from it faster. So you have to deal with those kind of different pipelines to aggregate those. And finally, the visibility is expected at across different geographies and 160 to be precise locales because of the kind of footprint Uber has in terms of getting a visibility for these kind of messages in these kind of languages. Because with systems, if you don't translate a particular message in that correct locale, you will automatically quickly see the engagement drop, or people are not understanding that message very well. With that, wanted to sort of with that system, I wanted to talk. Hand it over back to Gaurav, and we'll talk about the suppression framework, which is built on the platform that we discussed before, and that is an intelligence piece as well. And Gaurav is going to sort of go delve deeper into the suppression piece of it.
Thanks, Manny. So like Manny said, there's a lot of different pieces at play here, so we just wanted to pick one of those. We have described when to send a message, how to find which channel is more likely a user to engage with. Just as that is important, there's also another thing that is even more important, when not to send a message out. So when a city is in distress, something bad is happening in a city, a terrorist attack, a hurricane, natural calamity, we don't want to be insensitive and send marketing comms during that time. So what we have built is a suppression framework where we can have multiple models running and deciding whether a particular communication should be sent or not. One of those examples could be city-based suppression. Another example could be a user-based suppression. We want to measure how a user is doing over time and how effective this particular communication is. You can think of it as a control group of communications. We also have frequency rate limiting, meaning we should not be spamming users with a lot of messages. So all of that is abstracted away from a suppression framework here. So what we are seeing right now in this picture is hundreds of Uber services trying to send a message out through the gateway. Within that gateway, we first check, are we allowed to send this message out through this suppression framework? Suppression framework itself relies on other Uber services. Uber is famously a microservices architecture. So we rely on user information being pulled from other services, Cassandra as the feature store, like Manny said, and experimentation platform, which we have discussed publicly before. We also have a batch pipeline. For batch use cases, like we want to communicate with a driver that something is wrong, don't go into that area. At a really, really fast pace, we have a Kafka pipeline built in where we publish all the messages to Kafka and then process them through the platform via suppression framework. And finally, as a result and a side effect of the suppression framework, it can issue actions, which one of those examples could be publishing the suppressions to a third-party tool, because we also use some of the third parties to send the communications out. So we want to push this information out as fast as we can to these third parties as well. Diving deeper into a city-based message suppression, what we do is we have a scheduled Spark job, which is pulling data from Hive